Hello viewers, so we have this question that says an auditorium measures 40 by 20 by 12 meters. The density of air is 1.20 kgs per cubic meter. They're asking to say what will be the volume of the room in cubic feet and the weight of air in the room in pounds. So let's see how we can calculate that. Given this information, the volume of air will be given by LBH. So L multiplied by B multiplied by H, where L is length, B is breadth, and H is height. Given the information we have 40, so it will be 40 meters multiplied by 20 meters multiplied by 12 meters. So when we do mathematics here, what we are getting is 9,600. And this will hold units of cubic meters, since we have meter multiplying by another meter, which is also multiplying by the other meter. So we're having our volume is 9,600 cubic meters. Now, this is our volume in cubic meters, but we are told to say we need to find this volume in cubic feet. So let's go ahead and find that volume in cubic feet. To change volume from cubic meters to cubic feet, the conversion we need is 1 meter is equal to 3.2808 feet. So this is the conversion we need. 1 meter is equal to 3.2808 feet. So now let's use this conversion factor to convert from cubic meters to cubic feet. So what we have is, we always start with what we have. We have 9,600. This is cubic meters, and we are converting it, so we are bringing our conversion factor there. Down here, since we want to cancel meters, we're going to put 1 meter here is equal to 3.2808 on top there, and this has the units of feet. All right. So when you look at what we have here, we have cubic meters here, and we only have meters there. So what we need is, we need to convert this also. We need to change this to cubic meters and change that one also to cubic feet, so that as we do our mathematics, we'll be able to cancel out units. So let's do that. How do we do that? To do that, we only need to cube this down part here and also do the same to the upper part there. So you find out that when you say 1 meter to the power of 3, 1 to the power of 3 is to 1. Meter to the power of 3 will give you cubic meter. On top there, feet to the power of 3 will give you cubic feet. For the value, we need to do mathematics there. So let's continue. We have 9,600 cubic meters multiplied by, now when we say 3.2808 to the power of 3, what we are getting there is 35. So we are getting 35.3134. And when we say feet to the power of 3, we're going to get feet to the power of 3 like that. Then down here, what we are getting is 1 cubic meter. So that's what we are going to get. Now that we have the same units, you see that this cubic meter will cancel with that cubic meter, and our units of interest will remain, which is cubic feet here. So all we have to do is multiply 9,600 by 35.3134, and our unit will be in cubic feet. So let's quickly do that. When we do mathematics there, what we are getting as our volume in cubic feet is 339. So we are getting 339,008.12 0.64. Yeah, 0.64, and this is in the unit of cubic feet. So this is our volume in cubic feet. This can also be reported in scientific form, where we are saying this can be 3.39 times 10 to the power of our decimal point to move 1, 2, 3, 4, 5. So to the power of 5 cubic feet. So this is the answer that we needed for the first part. So we found our volume in cubic feet. So the first part is done. Let's look at the second part, where we are finding the weight of air in the room in pounds. So for that one, we need to find our weight in pounds. All right, so let's look at the second part. The second part is asking us to find the weight of air in the room in pounds. Now we're given to say the density of this air is 1.20, and this is having the units of kgs per cubic meter. So the first step is to find the mass of the room. So density is given by mass over volume. And making mass the subject here, our mass is equal to density multiplied by volume. So our density is given to be 1.20, and this is in the units of kgs per cubic meter, multiplied by, remember the volume we found in the first part there, 9,600. And this is in the units of cubic meters. Now we're using the volume in the units of cubic meters instead of cubic feet so that we can cancel our units. Remember, the density is having the units of cubic meters here, so they need to match with the units we have for the volume so that they cancel. So you find that this and that will go, and our answer will be in the units of kgs, of which that's the mass we want. So let's do mathematics. When we do our mathematics here, 1.20 multiplied by 9,600, according to my calculator here, I'm getting 11520 kgs. So yes, I'm getting 11,520 kgs. 11,520 kgs is what I'm getting when I do my mathematics there. So yeah, we have our mass. The next step is just to find our weight now. So our weight is equal to mass multiplied by acceleration due to gravity. So this is equal to, our mass is 11,520 kgs, and this will multiply by acceleration due to gravity is 9.81, and it will have the units of Newton per kg. And when we do mathematics there, you can see kg and kg is cancelling. This kg is going with that kg, and our answer will be, according to my calculator again, I have 11,3011.2 newtons. So this is our weight in newtons. This is our weight in newtons. 11,3011.2 newtons. Now that we have our weight in newtons, all we need to do is convert it from newtons to pounds. Now to convert from newtons to pounds, the conversion we need again is 1 newton is equal to 0.225 pounds. So that's what we have as our conversion. 1 newton is equal to 0.225 pounds. So let me use the left-hand side to find our answer. So what we have there is, we have 1130 11.2, and this is in the units of newtons. So to convert from newtons to pounds, we have that conversion. So this will multiply by, on the other side, we have, down here, we're going to have 1 newton, and on top there, we're going to have 0.225. So 225, and this is having the units of pounds. All right. So we're putting newtons down so that the unit of newton can cancel and our unit of interest, which is pounds, remains. So let's punch our calculators again. So according to my calculator, what I'm finding here is 25,427.52 pounds. So this is what I'm getting, and this can be reported as 1, 2, 3, 4. So we can report it as 2.54 times 10 to the power of 4 pounds. So you can report it in this format, or rather in that format. Still, your answers are basically correct. The first part is just standard form, and the second part is scientific notation. So still, the answers are still the same and correct. So this is how we go about this question.